In the realm of science and cosmic mysteries, the question of what existed before the Big Bang has stirred debates and intrigued minds for centuries. This profound question doesn't just challenge our understanding of the universe, it challenges the very boundaries of human knowledge. Imagine standing at the edge of existence, staring into the vast darkness, and wondering what lay there before our universe was born. The moment of the Big Bang marked the beginning of time, space, and everything we know, but was there a moment before? Could there have been a state of nothingness, a silence before the cosmic orchestra began? And if so, what was it? Or perhaps there was something far more terrifying that existed before time itself. As we dive deeper into this question, science takes us on a journey beyond the universe's origin into concepts that defy our understanding. Physicist Brian Cox, known for his exploration into the wonders of the universe, suggests that something terrifying might have existed before the Big Bang. He challenges us to rethink our concept of reality, time, and space. In this exploration, we'll examine the science, the theories, and the jaw-dropping mysteries that might explain what existed before everything. We'll look into ideas like cosmic inflation, quantum fluctuations, dark energy, and even multiverses. The answers we've uncovered might just shock you, but they could also unlock new understandings of our place in the cosmos. Get ready to dive deep into a world beyond imagination and science, where the unknown still looms in the shadows, leaving scientists astounded and sometimes even unsettled. Let's explore what existed before the Big Bang and why these theories challenge everything we thought we knew. To understand what might have existed before the Big Bang, we first need to carefully examine what the Big Bang actually was. The Big Bang, as scientists define it, refers to the moment when the universe became incredibly hot and dense, expanding rapidly to set off the creation of all matter, energy, and cosmic forces. When we look up at the night sky, we see evidence of this hot beginning, with galaxies spreading out in all directions from a central point. But why did this happen? And was there a time before this dense, hot origin? According to the theory of cosmic inflation, there was indeed a before, and it was far from empty or peaceful. Cosmic inflation suggests that before the Big Bang, the universe was in a state that was cold, empty, and stretched out, almost like a vast vacuum. However, this vacuum wasn't completely empty. It contained an immense amount of energy that powered the rapid expansion of space itself. This expansion, called inflation, happened so quickly that it essentially laid the groundwork for everything that would follow. In a fraction of a second, space stretched at speeds beyond comprehension until the expansion slowed, and the energy transformed into matter, particles, and the forces we recognize as the Big Bang. But what was the nature of this energy? Why did it suddenly inflate the universe, and why did it stop? Scientists believe that this cosmic inflation created patches of the universe, each experiencing its own Big Bang. Imagine a fabric stretching endlessly with tiny bubbles forming here and there. Each bubble represents a universe, including ours. This concept, called the inflationary multiverse, implies that there are potentially infinite Big Bangs and an endless number of universes. Ours is just one of many. This vast, mind-bending reality challenges our understanding of the universe itself and leaves us with the question, what else is out there? The concept of nothingness before the Big Bang is theoretical, not real, at least according to our current understanding. Even if you removed all energy, particles, and radiation from the universe, it would still not be truly empty. Our universe is filled with dark matter, dark energy, quantum fields, and other forces that create an inescapable tapestry of something, even in its most vacant form. Even if we imagine stripping away all these forces, leaving a dark void, the universe would still create new forms of energy. This fact alone is baffling to scientists as it suggests that true nothingness might be impossible within our cosmic understanding. As we probe deeper, we find that space itself has properties, rules, and constants that do not allow it to be completely void. Imagine creating a region with absolutely nothing in it, no particles, no radiation, and no energy. But quantum fields and fundamental constants still exist, meaning that this nothingness has properties. For instance, there's a phenomenon called zero-point energy, which represents the lowest possible energy state of quantum fields. In this state, particles can still briefly appear and disappear, creating a ghostly echo of activity even in what should be empty space. This defies our concept of a true void and suggests that even before the Big Bang, there was something that scientists are only beginning to understand. One of the most astounding theories in modern cosmology is the idea of eternal inflation. If inflation could cause our universe to exist, it's possible it could continue indefinitely. Brian Cox describes a terrifyingly vast inflationary multiverse where universes are endlessly created and continue expanding. Imagine each Big Bang as a spark igniting a new universe while inflation persists in other areas, creating countless other universes. This process could, in theory, go on forever. This idea of infinite universes gives birth to a fascinating concept of a fractal universe, where every new universe has the potential to create its own Big Bang. Each universe exists as a separate, self-contained realm unaffected by the others due to the rapid expansion of space. For scientists, this theory is both exciting and unsettling as it suggests an endless multiverse with no ultimate beginning or end. What if our universe is just one speck in a colossal cosmic structure, expanding and creating forever? And what if the terrifying truth is that there is no before or after, but simply an eternal cycle of universes forming and decaying? Our understanding of nothingness changes when we consider quantum field theory. According to this theory, the universe isn't just a collection of matter floating in space. Instead, it's a network of energy fields that fill the cosmos, interacting to create everything we observe. These fields are like invisible oceans, with particles acting as ripples, waves, or disturbances. Even when fields are at their lowest energy level, known as the vacuum state, they are still active. Particles can appear and disappear in these fields, borrowing energy temporarily before returning it. This phenomenon gives rise to virtual particles, entities that briefly exist and then vanish, leaving behind a faint memory of their presence. The concept of virtual particles challenges the notion of a true void. Imagine an empty universe where all matter, radiation, and energy are removed. Would you have complete nothingness? According to quantum field theory, you would not. Even in a vacuum, fields would remain active, occasionally producing fleeting particles. This constant activity in what should be nothing suggests that the universe doesn't understand our concept of emptiness. The fields and forces persist, filling the universe with an underlying energy that prevents absolute nothing. This insight raises an intriguing question. If fields create particles and particles create matter, then could the universe itself have emerged from this nothingness filled with quantum fields? Dark energy, a mysterious force that currently drives the accelerated expansion of our universe, might hold some answers. Could dark energy have existed before the Big Bang? Some theories propose that dark energy, in a much stronger state, could have powered the inflationary phase, allowing for rapid expansion. The presence of dark energy implies that even if our universe were emptied of all matter and radiation, this force would continue to stretch the fabric of spacetime. This idea leads to an unsettling thought. If dark energy was present before the Big Bang, it might have shaped the conditions that led to the birth of our universe. Could dark energy be the silent architect of cosmic inflation or even the true origin of our universe? Another theory offering an alternative to the Big Bang as the ultimate beginning is cyclic cosmology, the idea that the universe goes through endless cycles of birth, death, and rebirth. In this model, the Big Bang is not a one-time event but rather part of a cosmic rhythm where universes expand, collapse, and then re-expand in a new cycle. This theory proposes that our universe might have been reborn from the remnants of a previous universe. The process of contraction and expansion in a cyclic pattern would mean that there was never a true beginning but instead an infinite sequence of universes emerging, evolving, and renewing themselves. Cyclic cosmology raises profound questions about time as it suggests that time itself might be circular rather than linear. If this theory is correct, it could mean that what existed before the Big Bang was simply another version of the universe, one that collapsed only to give birth to our current universe. Primordial gravitational waves are another fascinating concept that might hold clues to what existed before the Big Bang. Gravitational waves, ripples in spacetime caused by massive cosmic events, could potentially carry information about a pre-Big Bang state. Detecting such waves would provide direct evidence of a previous cosmic state, unlocking the mysteries of what came before.